Hi guys, my name is Yash. I'm a ECBA certified business analyst. In this project, I have created a formula-driven sales analytics dashboard for ElectroMart India. So ElectroMart India is a fictional consumer electronic distributor. The company sells products such as televisions, refrigerators, air conditioners, washing machines, and kitchen appliances to different retail partners across India. So as you can see, one of the main highlights of this project is that the analytical calculations are formula driven. So I have used functions such as sum, SUMIFS, COUNTIFS, IFERROR, index match, SUMPRODUCT, COUNTIF, max, min, RANK.EQ, and conditional formatting. So this makes the workbook transparent and easy to audit because every dashboard value can be traced back to a formula and ultimately to the raw data sheet. So what is the purpose of this sheet? I'll begin with the raw data sheet because this is the foundation of the complete workbook, okay? Each row represents one invoice level transaction. The data set contains 70 invoices covering the full financial year from April 2026 to March 2027. Every KPI, table, chart, and heat map value is derived from this sheet. Now, as you can see, the date column, this is the date column here. So I'll just select it. So the date column records when each transaction occurred. It is used for financial year reporting and month-on-month analysis. Then there's the region column. So the region column groups transactions into North, South, East, West, Central, and Northeast. This is used for regional revenue, order, AOV, share, ranking, and heat map calculations. And moving on to state and city. As you can see, state and city provides more detailed geographical information. Although the current dashboard summarizes performance at regional level, these fields allow me to analyze to extend to state-wise or city-wise reporting. Then there's product, as you can see. So product identifies a specific item sold, such as smart TV 55-inch, split AC 1.5 ton, refrigerator 350 liters, or washing machines that's 7 kg. Moving on to category. So as you can see, category groups the individual products into broader segments: television, air conditioner, refrigerator, washing machine, and kitchen. This field is especially important for regional or category heat map. So moving on to customer. So I'm explaining you each column because it's very important to understand data set before going forward with the dashboards, KPIs, and region breakdown. Okay. So the customer column contains the retail partner or dealer purchasing the product from ElectroMart India. Now examples include Chroma, Vijay Sales, Vilas Digital, Bajaj Electronics, and other regional dealers. Moving on to units. So unit represents the selling price per individual units. Okay. I'm sorry. The units represent the quantity sold in a transaction. So how many transactions have happened? So that's units. Okay. Unit price is it represents the selling price per individual unit. So yeah, as you can see, smart TV selling price is around 48,900, and there are like 12 units sold. Okay. So yeah, so basically 12 units are given to Chroma Mumbai, and the revenue would be 5,86,800 rupees. Okay, so revenue is calculated field rather than a manually entered value. The formula multiplies unit by unit price. Perfect. So that's the calculation. That's why we use this formula. You see, we actually multiply I8 into J8. Okay. So if I double click on the formula, you see I8 into J8. Perfect. That's how we get the revenue. So as you can see, this completed data set contains 70 invoices, 529 units sold. Then the total revenue is 20 lakhs and 46,000 40,461 is the average listed unit price. Okay. So the 40,461 figure at the bottom is a simple average of the unit price column. So that's why we have used like the average of it. Okay. This represents the average listed unit price across the recorded invoice lines. So yeah, that's that. And then we move on to the dashboard. Okay. Okay, first we'll go through a KPI sheet. Let's understand the KPI calculation first. So after preparing the raw data, I created a separate KPI calculation sheet. This sheet acts as a calculation layer behind the dashboard cards. Each dashboard type reference on one KPI cell, which keeps the workbook organized, transparent, and easier to troubleshoot. So the total revenue value would be like 20 lakhs, okay? And how we get it is, as you can see, we have used the formula is equal to sum bracket raw data K8 and K77. So basically, as you can see, total revenue measures the complete sales value, right? Generated during the current financial year. I've used sum because the requirement is simply to add every valid value in the revenue column. So why this formula? Because sum is the most direct and efficient function when no condition is required. So yeah, I think you get that. So we have chosen it from the raw data column. So this column, that's how you have written raw data and then K8 into K77. Okay. Here we have used the count function. Um, so total order represents the number of invoice records. Since every valid transaction contains a date, I used COUNTIF on the date column to count all non-blank invoice rows. So why COUNTIF? Because COUNTIF counts non-empty cells. It is appropriate here because data is mandatory for every invoice, right? So it only counts the non-empty cells. So in the larger production model, an invoice ID field would be preferable for counting distinct invoices. In this project, one row represents one invoice, so counting dates is valid. Okay. Then moving on, I'm so sorry. Moving on to total units sold. And here we have done same thing which we have done for revenue. We have used the sum function. So total units sold measures the physical sales volume. It complements revenue because of high revenue. Results may come from either high volume, high pricing, or a combination of both. Okay. So yeah, that's how we use that. So you may think, what is this raw data? Raw data is this sheet, okay? And what is I8 into I7? So that is a total units sold there. And how we get that is basically what we do is we put the raw sheet column and then we put exactly where in the sheet we want it, right? So if you go in the raw data, you see this unit price is in, so units is in I, and that's how we do the sum here, okay? We take these I and we put this here. So that's why we have mentioned raw data here. From this sheet, we get this, okay? So anyway, let's move on to AOV, that's average order value. Now, as you can see, the average order value here is 2,86,022. What we have done here, we have done, so here the average order value, we have done C7 by C8. So what is C7? As you can see, C7 is the total revenue and C8 is the total orders. So that's how we have got the average order value. So average order value shows the average revenue generated per invoice. It is calculated by dividing total revenue by total orders. This helps management understand the typical monetary size of a transaction. So why not average on the revenue column? You technically could use average raw data K8 to K77 because each row represents one order. It should produce the same result. So however, I use total revenue divided by total orders because it connects directly to the two headline KPIs and clearly communicates the business definition of AOV. Okay. So here, if you notice, we didn't do the raw data and some part because it was not needed. Then there is average unit per order. It's 7.6. So average unit per order shows the average number of products included in an invoice. It helps distinguish whether revenue is being driven by larger order quantities or higher unit prices. So yeah, I think it justifies it. Then we move on to highest single order. The highest single order is 5,86,800 rupees. Now, as you can see, max, we have used the max function. It identifies the highest invoice revenue in the data set. So we have used the raw data and we have used K8 and K77, basically, which shows the revenue column. And max is showing the highest revenue. The lowest single is min. We have used the lowest value. Okay. And then we have just written a manual benchmark here because there was no so there was like no previous year figures there, so that's why we have just written the manual benchmark so that we get the year-on-year growth. So normally, as you can see, since the workbook contains transaction levels data only for the FY 2026-2027, the FY 2025-26 figure, that the last year figure is maintained as a benchmark input. In real organizations, this value could come from an audited financial report, an ERP system, or a separate historical data set. Okay. And there's year-on-year growth. Formula, as you can see, is C7 minus C14 divided by C14. What is C14? C14 is prior revenue. C7 is the total revenue. Okay. So I subtract the prior revenue from current revenue and divide the differences by prior revenue. Okay. So the result shows the current revenue is 74.71% higher than the selected prior year benchmark. So the project demonstrates 74.71% growth against the benchmark. Okay. And moving on to unique customers, we have unique customers. We have used the value of unique customers is 43. We have used array constraints here, an array formula, and basically we have used SUMPRODUCT. Okay, SUMPRODUCT one COUNTIFs. Then we have used a raw data column, and yeah. So as you can see, the customer column contains repeated customer names because the same retailer may place multiple orders. Therefore, count here would count transaction, not distinct numbers, not distinct customers, right? So I have used SUMPRODUCT with COUNTIF to perform a distinct count. So how it works, if one customer appears 4 times, this example, Vijay Sales is appearing 4 times, COUNTIF returns 4 for every occurrence. Each occurrence then contributes 1 divided by 4 or 0.25. So adding the 4 occurrences give 1. Therefore, every unique customer contributes exactly 1 to the final count. So as you can see, this is the same distinct count approach is used for 15 unique products and 6 unique regions, okay? Okay, so yeah, I've like used the same distinct count pattern on the product and the region columns because underlying business requirements is identical. Count each distinct value once, regardless of how many times it appears. So yeah, I've done it same for the unique regions and unique products. Okay, so I hope you get the point. Perfect, let's go to the region breakdown sheet. So the next calculation layer is the region breakdown sheet. This behaves like a formula-driven pivot table. It summarizes revenue, orders, average order value, revenue share, and rank for each region. I used formula instead of manually typed values, so any changes in the raw data automatically recalculates the summary. Now, as you can see, we have used SUMIFS. So why we have used SUMIFS and not SUM? Think about it. So as you can see, the first argument is that the range to be added, which is raw data revenue column. Second argument is the region column. And final argument is the region name in the current summary row. So for north, the formula means sum revenue where region equals north. So why SUMIFS? I use SUMIFS because the requirement is to aggregate a numerical measure based on business condition. It's also scalable because additional conditions could later be included, such as region plus category, region plus month, or region plus customer type. Now, as you can see, regional orders is equal to COUNTIFs. So the formula for COUNTIFs is raw data C8 to C77, comma B8. So COUNTIFs counts the number of invoice rows associated with each region. Unlike SUMIFs, it doesn't. So here I've used SUMIFs, okay? I've used here COUNTIFs. It basically counts the number of invoice rows associated with each regions, right? So unlike SUMIFS, it does not need a sum range because the objective is to count qualifying records. So why COUNTIFs instead of COUNTIF, you may think? So one criterion technically allows COUNTIF. However, COUNTIFs was used for consistency and future scalability. Additional criteria can be added without changing the formula structure. Moving on to the average order value, we have used IFERROR C8 by D8, comma 0. C is basically revenue, okay, C column, and D is orders. So as you can see, regional AOV is calculated by dividing the region's revenue by its number of orders. I wrap the division in IFERROR. If a newly added region has 0 orders, Excel would otherwise display division/0. IFERROR returns 0 instead, keeping the dashboard clean and usable. So why IFERROR? Because error handling is important in production reporting because dashboard should not expose technical error codes to business users. Okay, that's why we use that. Again, percentage of the total, we have used IFERROR again. Now, percentage of total measures the contribution of each region of total revenue. The individual region revenue is divided by combined revenue of all 6 regions. The revenue range is locked up using absolute references, so the denominator remains fixed when the formula is copied downwards. As you can see this dollar sign, there's a dollar sign here. Okay. Okay, so there isn't a dollar sign. I have not put a dollar sign. I have to. So I'll just put it I here and then $8. Then it's the same here. I'm doing it slow because I want you to know exactly what I'm doing, okay? Otherwise, this is like very fast thing. And yeah, I think it's complete and it's enter. And what I do is I'll just use this. Perfect. Okay. So the dollar sign, as you can see, locks the total revenue range. So without absolute references, copying the formula downwards would shift the denominators and produce incorrect percentage. Okay? So I hope you get to understand what dollar signs is. Then we move on to rank. So we use this formula RANK.EQ because we are ranking the regions by revenue. So the value being ranked is the current regional revenue. This is C8. Okay. The value, the comparison range contains all regional revenues and is locked using absolute references. So here, as you can see, final argument is 0, which means the highest revenue receives rank 1. Perfect. That's why we have used. So as you can see, the current ranking, West is number 1, South is number 2, North is number 3, and so on. Okay. So rank kind of makes the performance hierarchy immediately visible and complements the regional bar chart. So moving on, as you can see, again, West is the highest performing region with a revenue of 59 lakhs 56,750, 19 orders and a 29.5% 75% revenue share. South ranks the second with 52 lakhs 34,950 and the highest regional AOV of approximately 3 lakh 27,184. And North ranks third with 45 lakhs 14,350. Together, West, South, and North contribute approximately 78% of total revenue. Now, this indicates that the business is heavily concentrated into 3 largest regions. Okay. Moving on to the dashboard revenue. Mhm. So the dashboard sheet brings all major calculations together in one management-facing view. The user does not need to review the 70 individual invoice rows. Instead, the dashboard communicates overall performance through KPI cards, regional analysis, product ranking, monthly trends, charts, and a category heat map. Okay. As you can see, the top line KPIs, total revenue is 2 crores. I'm sorry, I just said first 20 lakhs, it's 2 crores. Miscalculated. Total orders is 70. Average order value is 2 lakh 86,000 2022 022, and year on year growth is 74.71%. Now these cards provide an immediate executive summary. The dashboard does not repeat the underlying calculations. Each card links to one calculated cells on the KPI sheet. This separation keeps the presentation layer simple while the KPI sheet maintains the business logic. Now, you see we have used index match formula here. So the dashboard regional table mirrors the regional breakdown sheet. So I have used index match to retrieve the corresponding revenue, orders, AOV, and share for each region. Match kind of identifies the row position of the selected region, while index returns the value from the requested result column. You may think, why have we not used VLOOKUP instead of this? Why index match? So index match is much more flexible because the lookup and return columns are independent, right? It does not require the lookup columns to be the first column in the selected table, and it is less vulnerable to column insertions. So as you can see, the top 5 products here. First of all, I just want to like make you understand I've used index match for every region-wise revenue table chart. Okay, get it? It's basically index, then region breakdown. From the region breakdown, we go F8, F13, then we match north to region breakdown again, and that is to B8 and B13. Okay, comma 0. So yeah, I hope you understand it. It's very, very simple to understand, and yeah, I hope you get to know. So yeah, let's move forward. We have the top 5 products. It's a smart TV 55. It's split AC 1.5 turn, smart TV 65, smart TV 43, washing machine 7 kg. Okay. So as you can see, the revenue here is 2 lakh. It's sorry, 22 lakh 49,400, 19 lakh, 19 lakh, 17 lakhs, 13 lakhs. Okay. Like that it goes. Then there are orders and there are units. Now, the top 5 product selection ranks products according to revenue. This helps identify the products contributing to the greatest monetary value. The table also includes orders and units because revenue alone does not explain whether performance comes from higher sales volume or higher unit prices. For example, a premium television may generate strong revenue with fewer units, while a lower priced product may require higher volume to achieve a similar result. So, okay, I hope you understand this. We have used SUMIFS here. Perfect. So yeah, it's cool. Then moving on to month-on-month analysis. So in this month-of-month trends, we have used SUMIFS too. SUMIFS and COUNTIFs we have used here, okay? So as you can see, monthly revenue is calculated with SUMIFS using 2 date conditions, okay? The second contribution includes transaction occurring before the first day of the following month. So I have used eDate to dynamically identify the next month. This is more reliable than manually specifying the last date of every month because months contain different number of days. Now the raw date ranges are locked using dollar signs because they should remain unchanged when the formula is copied. The month reference remains relative, so H22 becomes H23, H24, and so on as the formula moves downward. Perfect. Then this is like the monthly business interpretation. As you can see, I'm not I'm able to see it. So yeah, Okay, perfect. So first, as you can see, April generated 12 lakhs 34,700, 7,200, and from 41 orders. Okay. Then May generated 19 lakhs 77,200 from 9 orders. The remaining months contains 2 orders each because the added demonstration dataset were designed to provide complete financial year coverage. October recorded the strongest revenue among the 2 other months at 9 lakhs 96,600 here. March recorded the lowest monthly revenue at 3 lakh 29,500. So the chart shows a significant concentration of revenue in April, followed by a much lower and comparatively stable pattern. So the chart's April peak is caused by distribution of sample transactions, not necessarily by a confirmed seasonal business trend. Now moving on to a regional chart. So the horizontal bar chart compares total revenue across 6 regions. So horizontal format was chosen because region names are categorical and the bar lengths make ranking easy to interpret, right? So as you can see, West has the longest bar, followed by South and North. The chart confirms the same pattern shown in the regional table. Now moving on. So we have the region and the category heat maps. So the heat maps perform a two-dimensional analysis by combining region and category. What we have used here, we have used SUMIFS. Okay. So the formula uses SUMIFS with two criteria. The first condition matches the region from the row label. Second condition matches the category from the column header. For example, the North television cell sums revenue where region equals North and category equals television. Okay, I hope you understand. So formula uses $B53 and $52. So what is $B53? It locks the region columns but allows the row numbers to change when the formula is copied downwards. And $52 locks the category header row but allows the column to change when the formula is copied across. These mixed references allow one formula to populate the entire heat map matrix accurately. So, as you can see, I've used SUMIFS everywhere here. Okay. So anyway, after calculating the values, I applied a 3-color conditional formatting scale. Lighter cells represents lower revenue, while deeper purple cell represents higher revenue. This converts a numerical matrix into a visual pattern, helping users identify high-performing combinations immediately. Okay, so yeah, I think it's very clear now. So as you can see here, television is the strongest. I'm sorry. So television is the strongest category in North. Okay, television almost has 16 lakhs of sale or revenue. And in South also it has around 17 lakhs, so it's very strong there. And as you can see, South has a very strong, like exceptionally strong washing machine revenue of 12 lakh 15,000, West has a broad and balanced product mix with meaningful revenue across all 5 categories. Central has no kitchen revenue in the current sample. Northeast has no air condition or washing machine revenue. So these value cell represent category gaps in the dataset and could help management identify areas requiring further investigation. Now, you see, a 0 could mean no customer demand, no product distribution, incomplete coverage, or simply limited sample data. Okay? So normally when you work with big companies, you won't get 0 there. Okay. Anyway, let's move on to the last sheet. That's the formula sheet where I've explained all the formulas which I've used. Now, first is SUMIFS. Okay. So what does SUMIF does is used when I need to add numerical measures subject to one or more business conditions. Then it's COUNTIFs. It's used when I need to count records satisfying one or more criteria. Then we use revenue divided by orders for AOV, average orders. So it is used to calculate average orders, okay, to its standard business definition. Then we use index match. It is used to retrieve calculated regional values into the dashboard presentation layer. We use IFERROR. It's used to keep the dashboard clean when calculations encounter zero denominators or missing values. Then we use SUMPRODUCT or COUNTIF. So we use SUMPRODUCT to calculate distinct customers, products, and region without requiring a pivot table. Both SUMPRODUCT and COUNTIF. Then we use RANK.EQ too. I have not mentioned RANK.EQ here. I would love to mention it. It actually ranks regions of product by revenue. Okay. Yeah, I think this is this was a great project, and I've used these. I've also used color scale conditional formatting, so I don't think so I need to explain that. But yeah, I think this project is great, and you see, I intentionally use formulas for this project because they make every calculation visible and easy to demonstrate in an interview. Summaries also recalculate immediately when the reference raw data range changes. A pivot table would also be a valid solution, especially for larger interactive analysis, but formulas were selected here for transparency and control. So I would explain my final business insights in the next video in a presentation. So yeah, I'll first end this recording here.